So again, we are rotating the same region as before, but around a different line, y equals -1. So that's a horizontal line, let's say here. And from the previous observation, if I need to draw either a vertical or horizontal segment, it's suitable to draw a vertical one so that we always see a top function given by this parabola and a bottom function given by the line y equals 0. And moving this segment, so this is at a certain point x, moving it from 1 to 3 will reconstruct our two-dimensional region. So when you rotate it, it will reconstruct the three-dimensional region. Now this rotates in this direction. So what happens to this segment when you rotate in this direction? Then it produces the following shape, which is a washer. So that's this area. How do we find that? That's the area of the big circle, which is pi r squared. And then minus the area of the small circle, so that's pi r squared, which you can combine as pi capital R squared minus small r squared. And that's the reason why we're subtracting these two areas. Sometimes people forget where this comes from and they just do the difference of the radii squared, but that's not the case. So our integral will be from 1 to 3, as I said. It's in the x, and we just need to figure out what these radii are. So let's look at the picture. The small circle is this one, so that's its radius. How much is that? Well, I'm going from this line to this line, so this is constantly equal to 1, right? From here all the way up to here, that's always the same, that's 1. So the little radius is 1. What about the big radius? So the big radius is this one. And how much is that? Well, it's 1 plus this part, which is given by the top function minus the bottom function. So that's just the expression of the parabola. And then I just fill out in the integral. So like this, and that's the integral giving you the volume that's requested.